Hey math students, Mr. Ray here. Uh, with this video, it's actually going to be a two-part video. We're going to be looking at the review package that I posted. It's actually given over 4 days, so they're entitled Review Day 1, Day 2, etc. So this should give you hopefully a reminder of what you learned in grade 9, and hopefully if you don't remember how to do it, it'll come back to you. Some of the things might be a little tricky, but this is important in order to go forward in grade 10, 11, 12, that you know these skills. You can't be messing these skills up down the road. It'll just lead to big trouble. Okay, so I'm going to do the first two days, day 1 and day 2 questions. So these questions, all these questions on these days, you're going to be submitting. Okay, so what I'm going to do is go through the pages. I'm going to explain the questions, and I'm going to do a couple of the questions to show you how you would do and explain. So if I was you, what I would do is, for example, when we're working on this one question, I'm going to explain it, do a couple examples. What I would do is maybe pause the video at that point and then go back to your pages, fill in the questions I did, and also add in the questions I didn't do. Okay. Now you may get to a question and you're not sure how to do it. That's when the class time comes in handy. I'd be happy to help out. Okay, this is not a test. This is a kind of a review so that you can get good at the stuff that you need to know. Okay. The other thing I would recommend is some of these questions have enough room for you to leave the answer, but a lot of them don't. So I would recommend that you do these questions on a blank page and then just hand in the blank pages when you submit your homework. Okay, we're going to have to move fairly quick with the short quadmester. So you'll be still working on, I don't expect everyone to finish all 4 pages and then before we continue on. That would take too much time. So I do urge you to do these as quickly as possible, get them all figured out. But we will be going forward with the Unit 1 lessons. So some of you might be working on the review still at the same time as you're learning the new stuff from grade 10. Okay, that's the way we'll do it. So the first day, integers in order of operations on the first page, BEDMAS. Remember that stands for brackets, exponents, division, multiplication, addition, subtraction. That tells you the order you do things. This is just based on the double signs. If you see 2 signs in a row, what you want to do is always change those to a single sign. Okay, so here's the little legend here. If the 2 signs in a row are the same, either both positive, like a plus positive, or subtract a negative, that changes to a single positive sign. But if you have a mixture, like a positive and a negative, doesn't matter the order, then that converts to a single sign, which is a negative sign or a subtraction sign. Okay, so in each of these, I would first of all fix the signs, and then just do the question. So for example, we have a positive 5 plus a positive 7. If you see a plus sign in front of a leading number, you don't really need to have that there. It doesn't add anything to it. If it's a 5, you know it's a positive 5. So I would change that to just 5, and then the plus positive changes to a single positive. And now you just do the math. 5 plus 7 is 12. Okay. Question E here. So again, you got that leading positive 11. So I just cut the positive off because it doesn't add anything. And this time I have a plus minus together. So that changes to a single subtraction. So 11 minus 12 is negative 1. Okay, so hopefully you get the hang of that. So always do in 2 steps. First fix the sides. And in each case you're removing the brackets as well. You can see each of my steps single sign and no brackets, so that's what you should do. Okay, when you have more than one, like when you have 3 or 4 steps, you would just go left to right. Okay, so now this one here, you're doing basically it's kind of the same as above, except a subtraction sign in between the two numbers. So positive 5, so that's just 5. Subtract a positive 2. That means we change that to just a single subtract. 5 minus 2 is 3. Okay, this one over here, we've got a negative 3 minus a negative 6. So this time I can't drop the negative, but I can't drop the bracket. So negative 3, and I have a minus a negative, that turns into plus. So negative 3 plus 6 is positive 3, so I just leave that as 3. So that should give you the hang of the rest of these. Okay, so again, do 2 steps. First step, you're removing the brackets, simplifying the double signs, and then last step is just adding or subtracting the numbers. It should be a lot easier to do once you've done the first step. Okay, again, now we have evaluate, and this time we have subtractions. Okay, so in this case we got positive 7 times positive 2. Okay, so I can rewrite that as 7 times 2, which is, so I dropped the positive because I didn't add anything. I don't have to put 7 times plus 2. That would be, pretty messy looking. Okay, so 7 times 2 is 14. This time, I got a negative times a negative, okay? So this chart up here also works for when you're multiplying two numbers with these signs. So if I multiply a negative with a negative, that means I always get a positive. So when I do my math here, I could write this as negative 3 times negative 5, but it's really not adding too much. In fact, I probably should keep the brackets there. So what I'm going to do is just do this one in one step. So I know the sign of the result will be positive because it's a negative times negative. So I could put plus, but I'll just leave it blank, which means it's positive 3. And now when I multiply, I'm not worrying about the signs. Just 3 times 5, 15. And we already knew the answer was positive, so that's why we could ignore the signs. Okay, now these ones here, you see these in brackets without the multiply signs. That's more high school. We tend not to use a lot of multiplication signs in grades 10, 11, 12. So when you see two numbers in brackets side up against each other, that just means negative 10 times negative 11. Okay, so you can use the same rules as we were using for the other questions. Now these ones are division. Okay, so in this case I've got, now I can write a division. You don't often see the division symbol in high school math either. Usually it's written as a fraction. So I'm just going to change this. So that's really 12 over 4, or 12 divided by 4, and that's equal to 3. Okay, this one here we're going to do the same thing. Now, the fact that both of these are negative, the rule that applied to multiplication also applies to division. So if I'm dividing two negative numbers, the result's going to be positive, just like when I multiplied two negative numbers. So I already know the answer is going to be positive. So it's 20 over 5. I basically cancel the two negative signs, and now 20 divided by 5 is 4. You can see I'm running out of room here very quickly on these ones, as you'll see on a lot of the other ones later on. Okay, question 5. This time we've got a series of adding, multiplying. This time we got to multiply with the multiply sign. Here we have multiply with the brackets. Okay, so we have to use BEDMAS, and this is where it's important. BEDMAS says that you always do multiplication and division before addition and subtraction. So you could tell, since these are in brackets, you're going to do that first, but that's also a multiplication. So what you don't want to do is do this and then add it to 2, because that would violate BEDMAS rules. So sometimes you can use brackets to kind of clarify what BEDMAS is telling you. What BEDMAS is saying is we have to do the multiplications first before we add them together. Okay, so in this case I've got negative 6 times 2, that's going to be negative 12, and then I'm adding negative 3 times negative 4. So remember the rule here. Sorry if you're not seeing that. So negative 6 times 2 is negative 12. Negative times negative is positive, and 8 times 3 is 24. So that translates into that, and then we just add them together. Now, one thing about when you're adding, you can actually change the order here. So I could actually put the positive 12 like in front of the negative 12. So I could have 24, positive 24 minus 12, that's 12. It's the same thing as if you do it in this order, but sometimes people like a positive subtracting another number instead of a negative adding to a positive. Okay, you have to be careful though, you can't just switch the number parts, the sign in front has to go with it. Okay, the 24 is positive, the 12 is negative. Okay, there's a couple here with square roots. I'm not too bothered if you're not sure what to do. Something like that, where the 3 times square root of 25, or sorry, 3 root 25, that's the same as 3 times whatever the square root of 25 is. Okay, so again, make sure you follow BEDMAS for all those. Okay, second page of day 1. We're doing fraction math. Okay, so the first part here is adding and subtracting, and the second part is multiplying and dividing. So actually adding and subtracting is the harder of the two types. And the reason for that is you have to have a common denominator, if you remember, when you add and subtract. Before you can add the tops, you have to have the same bottoms denominators. Whereas multiplying, it doesn't matter. So let's do a couple of these. So we have 1/2 plus 5/8. You can't just, please don't do, this is 6 over 10. That's really wrong. We have to change each of these to equivalent fractions. Okay, but we have to convert, make the same denominator for both. So a lot of people would think, oh, that's going to be 16. Okay, but it's actually 8 is the lowest common denominator. Because if I multiply the 2 by 4, I'm going to get 8. So I'm going to keep the 5/8, and I'm going to multiply the top and bottom of the 1/2 with a 4, because multiplying the 2 by 4 will give me an 8. And if I multiply the top, I get 4, and 4/8 is the same as a 1/2. And now, when you add these, okay, please don't make this 9 over 16. The denominators stay the same, and we actually add just the top, so that's equal to 9/8, which if you convert that into mixed fractions, so that's a so what we would do here is change that to 1 1/8. Okay, now I'm okay with leaving it like that, but if you want to get some practice in converting, that's fine. Okay, let's try this one here. This time we have a subtraction. So again, we want to, so there's my minus sign from there. There's my two fractions. So the first thing I do is figure out what common denominator am I going to use. So in this case, it's going to be 15, because 15 is the lowest number that can be divided by both of these. Okay, so usually you can multiply these two together, but you can see that didn't work with this one. So that's going to be a 15, that's going to be a 15. So what do we have to multiply this by to get 15? Well, that's a 3. So multiply the top and bottom by 3. So that's 9/15. Multiply, we need to multiply this fraction by 5 over 5, which is really the same as 1. So that's going to be 5 over 15. And just like before, the denominator is the same, but this time we subtract. So 9 minus 5 is 4/15. And we should also be checking to see if we can reduce these fractions. But in this case, we can't make these any smaller. I can't divide 4 and 15 by anything. It'll make it smaller. Okay, so that's adding and subtracting. Hopefully you remember how to do that. If I do multiplying and dividing, okay, this is the one that's actually easier because we just multiply the tops and the bottom. Excuse me. So 3 times 3 is 9. 2 times 8 is 16. Done. Okay, now you should also check for if it can reduce the fraction. And there's a bit of a trick there if you remember. You can actually do your reducing before you actually multiply. So if you know, I'm looking on the top and I have 3's. If I had something that could be divided by 3 down here, like if that was a 9, then I could actually, you know, divide that 3 by 3 and that 9 by 3. So I would actually have 1/2 over, I don't know, 3/3, and then multiply, and then I wouldn't have to worry about reducing because I've already done the reducing. Okay, now when you see a division, remember they're just like multiplication, but you actually change the second number, what you're dividing by. You change the second number. Well, first of all, you change the sign. Sorry, you change the operation from dividing to multiplying, and then you flip this second fraction upside down, so that turns into 8/3. Okay, so that's always. So if you were working with later on when you see maybe some mixed fractions, you want to change them to improper fractions or proper fractions before you do your multiplying. You never do a multiplying. You should never do a multiply with or division with mixed fractions. They should always be improper. Okay, now this 5 here is interesting because it's not a fraction, but the thing is every time you see an integer, you can immediately turn it into a fraction by putting it over 1. So 5 over 1 is the same as 5, so that's what we're going to do here, so we can use the same rule. So now it's just, and again, if I'm trying to reduce, there's nothing that can be divided by 5, or nothing that can be divided by 8. So it's going to be 40 over 3. Okay, now if you were changing to a mixed fraction, okay, the way you do that, 40 divided by 3, you can do this on a calculator, no problem. It works out to something like 13 point something. So that means you get a whole 13, whole number 13. Now to see how much of that 40 you've used up, you just multiply the number you got here with the denominator. 13 times 3 is 39. So we've used 39 of that, so we have 1 left over. So that would be 13 1/3. Okay. All right, that's the end of that page. Now this one here, this one, they kind of explain the rules a bit here. So this is a nice little reminder of what to do. Hopefully I've already talked about that, but this could be a reinforcement of what I've said. So in this case here, we're adding these mixed fractions. So just like I said a few seconds ago, want to change that into an improper fraction. So that's the first step we're going to do. So to change to an improper fraction, you multiply that number with that number and add it to there. So that's 2 times 3 plus 1. That's 6 plus 1, 7. So 7 is the new numerator. The denominator stays the same. And then we do the same thing with this. 2 times 1 plus 1, that's 3 over 2. Problem, since we're adding, we have to have this common denominator. So we're going to switch that in this step. And that common denominator will be 6. So I can put that in right away, figure out what we got to put on the top now. So this would be multiplied by 2 over 2 to get the 6. So that means there's going to be a 14 on the top. This has to be multiplied by 3, 3 over 3. So that's going to be a 9. So that's going to be, remember, add the top, 23 over 6. And I can't simplify that in terms and leave, sorry, I can't reduce that. But if I wanted to, I could change it into a mixed fraction. Again, I usually prefer Once you get to grade 11 and 12, you almost want the numbers to be in mixed fractions. Sorry, improper fractions unless it's a word problem. Okay, so that's how you leave that. Multiplying fractions. Here's a case where you can actually reduce. That's why I've kind of identified this one. So in this case, before we multiply, you can actually check and go, oh, I could divide that by 5 and that by 5. So when you do that, you can cancel that 5, it becomes 1, and this becomes a 5. So that's 1 times 3 on the top, and 9 times 5 on the bottom. See, the problem is if you don't do that first, we're going to get something like 15 over 225, I think. And that can be reduced, but it probably would take you longer to reduce that to this than doing this early step. So I always recommend it to do that. Here's a division, and this time we have an integer divided by a fraction. So we want to change that integer to a fraction just by putting it over 1. And since that's a division, I'm going to change that to a multiply and then flip. So it's negative 5 over 4. You notice I put the negative sign on top. That's good math practice. It doesn't, if a fraction's negative, you could write it as negative 4 over 5 or 4 over negative 5 or with the negative sign up front. Okay, all three of them work, but most of the time we really don't like to have the negative on the bottom. Okay, and in this case, I'm going to multiply first, and I get negative times negative, which is positive. 6 times 5 is 30, and on the bottom over 4. Now I notice, hey, I could have actually reduced that, but I can still reduce it. Divide the top and bottom by 2, so I get 15 over 2, or 7.5. Okay, now you could have reduced up here, but I saw that, but I didn't want to get it too messy with the negative sign and possibly lose the sign. So as long as you get down to the final answer, I don't care too much whether you reduce at before multiplying or after. Okay, let's go down to the next one here. This is again some more BEDMAS, but it's also using fractions and that. So let's do this example here. So I got 8 minus 2, and then now I see this mistake all the time. Okay, people sort of read left to right and they go, oh, 8 minus 2, that's 6, and they change it to a 6 times whatever this is. That is not right, because we actually have to evaluate this first, then we have to multiply it by 2, and then we subtract it from 8. So again, this is showing you how BEDMAS works. Now the first thing I have to do is make equivalent fractions here so that they both have the same denominator. In this case, I want the denominator to be 8, so I'm going to leave the 7/8 as it was and then convert that by multiplying it by 2 over 2. So that would be 6 over 8. Sorry for my writing. Okay, so now we got 8 minus 2 times, now on the bottom here we got 8, and on the top we've got 13. Okay, now we get to this step. Now I really, the next step I have to multiply these two together, but sometimes you can think ahead and go, I'm going to get something over 8 here, and I want to subtract that from 8. So I know I'm going to have to convert this to a fraction anyway, so might as well do it now, save myself one step. So if I want that, and I know this is going to be over 8, so does that. So now remember, this is like 8 over 1. So if I want to make the bottom 8, I have to multiply the top and bottom by 8. So that leaves a 64 on the top. And this 2 in front is like 2 over 1. So really you just multiply the top by 2. The bottom stays the same. So that's going to be minus 26 over 8. Okay, so we finally got to the point where we can combine these. We got the same denominator. 64 minus 26, that's 38 over 8, which is 19 over 4. That's improper. Okay, so you can see this takes up quite a few steps. So it's always better to do this on a separate sheet. Okay, so be careful about that thing there. Okay, don't just don't read left to right and do the math. You have to do according to what BEDMAS tells you to do. Okay, this one is simplifying. So what simplifying means is you combine the like terms. Okay, simplifying also means expand the brackets, which is some of these other ones. But in this case, since there's no brackets, it just means combine the like terms. Okay, so what is a like term? A like term is a term that has the same variable to the same exponent. So just because they have x's doesn't mean I can combine them. They have to have x with the same exponent. So I'm going to identify I've got that term is an x squared term, that term is an x squared term, and those are the only ones. Okay, so I could just reorder these if you want to, but I'm just going to kind of read it out loud. I have 2x squared minus 4x squared, so that leaves negative 2x squared. Now when you have a whole list of terms here, it's always kind of good form to, as you use them, as you simplify them into something else, kind of cross them off, because you'd be surprised how many times you forget one of the terms, or maybe use it twice by accident. So now we're looking at x terms, so I have a plus 3x and a plus 5x. So you're just adding the coefficients together, positive 3 plus positive 5 is positive 8, cross them off, and we're just left with a single like term, the constant. It has no x's, so it's just by itself. So that would be this polynomial simplified, or this expression simplified, and you can try these other ones. Here's where it says evaluate. So what evaluate means is you actually plug in a value for the variables. So in this case we've got this expression here with some brackets, and we want to set x equal to 3, y equal negative 2, z equal negative 1. Now when you evaluate, there's two ways you can do it. You can simplify this first, like get rid of the brackets, combine the like terms, and then plug it in, and a lot of times that's a better way of doing it. So that's what I'm going to do. The other way to do it would just be to plug it in now. Okay. Now these examples, it's not a great deal of difference in time, but there's some cases if you had something like this where you plug in for x, it would make more sense to simplify first and then plug it in. Okay, so in this case I will expand this, so it's going to be 3x. Now when we expand here, we multiply the positive 2 with both of these, so positive 2 times y is plus 2y, positive 2 times negative z, that's going to be negative 2z. Okay, and now we actually plug in the values, so x is 3. So you can see I put the number with brackets around it wherever that variable is shown, and then I have a plus 2y, and the y is negative 2, and a minus 2z, the z was negative 1. Okay, now we're just going to, don't try to do too much in each line. So I have a 9 from there, I have a negative 4 or minus 4, and negative negative, that becomes plus 2, and now I can just, 9 minus 4, that's 5, 5 plus 2 is 7. So there's my final answer. Okay, so hopefully you remember doing some of those last year. Okay, how many more pages we got? 3 more pages, and then we'll stop and do the other page, day 3 and 4 at once. Okay, so in this case, again, distributive property, that's where you multiply something outside some brackets with multiple terms inside. Okay, and we'll be doing this and probably the first couple lessons in grade 10. Make sure you're good at that. Okay, so what we're doing here, multiply the 4x with the 3x squared and also with the negative 7x. So when you're multiplying basically 4x times 3x squared, and you could write that as an intermediate step, but I'm just going to do it in one step. So first thing we do is multiply the coefficients, the number parts together. 4 times 3, that's 12. And then I have x times x squared. So remember, x squared is just x times x. If I multiply by another x, that's going to be x cubed. You basically add 1 to the exponent. So that's x cubed, right? And then we do the same thing for this other multiplication. So I have 4 times negative 7. So that's negative 28. And then I have x times x this time. That gives us x squared. And that's all we can do. These are not like terms. You can see I have an x cubed and an x squared. I can't combine those, so we just leave them as they are. And you can try a couple of these. These ones here, I'm pretty sure that you'll be combining, I think, a couple of terms here. After you've multiplied, there's still some simplifying to do. Okay, there's a whole bunch of solving equations, mostly on the next lesson, but let's just do an example here. Maybe we've done a couple of these already in previous videos, but in this case we have something different. We have x on both sides. So how do I get x by itself? Well, you just do a separate step first. I want to keep the x over here. So I want the x on this side and I want the number on this side. That's what I want to end up. X equals a number. So basically these two terms here I want to get rid of. And it doesn't really matter which order you do it. So let's do the 3x first. So I want to get rid of this term here because I don't want any x's on the right side. So if I subtracted 3x on both sides, that would just clear that one completely out. I'm left with just 38. If I subtract 3x from here, 8x minus 3x, that's 5x. Okay, so I successfully got rid of that. Now I want to get rid of this minus 7. The way we do that is we add 7 to both sides. So if I add 7 to this side, cancels out the minus 7, just left with 5x. And if I add 7 to this side, I get 45. And now we just divide both sides by 5. And we get x equals 9. Okay? And the thing about solving equations, you can always check to see if you're right. Plug this back in. I won't do it for this case, but you should, whatever I get 8x minus 7, when I plug in x equals 9, it should be the same as 3 times 9 plus 38. Okay? Here's a trickier one where you have multiple fractions in an equation. Remember, the equation has the equal sign in the middle of two expressions. Now, so what we want to do here is always get rid of the fraction first. Okay, so the first thing I'm going to do is what do I need to multiply everything by to get rid of the 5 and the 3? Well, if you multiply everything by 5, it'll get rid of this, but it won't get rid of this. If I multiply everything by 3, it'll get rid of this, but not this. So you have to pick a number that's a multiple of both of these. The lowest common multiple, just like you were doing earlier. So in this case, I want to multiply everything by 15. Okay, so now that includes every term, not just the fraction parts. That also includes the constants. Okay, you can't just pick and choose what you multiply by 15. It's got to be the whole left side, the whole right side. So when I do that, the first thing, basically when I multiply by 15 in a fraction, it just multiplies with the top. It's like multiplying by 15 over 1. So I have 15x over 5 plus 4 times 15. equals 15x over 3 plus 2 times 15. Okay, and you can see every one of these terms got multiplied by 15. If I forgot one, and that creates a whole world of trouble because your answer is going to be wrong for sure. Now, the cool thing about this next step, you're saying, well, this just looks more complicated, right? Well, these fractions here actually turn into integers because of the way we did it. So 15 over 5, that's 3. So I get 3x. That's a 60. 15 divided by 3, that's 5. And the x is still there. And this is 30. Okay. So again, it's kind of like this question down here at this point. I've got x terms on both sides. I got numbers on both sides. I need to simplify that. So I like to keep the x's on the left side. So I want to keep that term because it's an x on the left side. I want to keep this term, but I want to get rid of these two. So the first thing I'm going to do is subtract 5x from both sides. When I do that, I get negative 2x. Since 3 minus 5 is negative 2. Okay, and the 5x is gone because I subtracted 5x. Equals 30. Now for this, I'm going to subtract 60 from both sides. So that leaves me negative 2x. So 30 minus 60 is negative 30. Okay, and now I'm at the point, I've just got an x term equals a constant, but I have to divide. Now you always divide by whatever that number is. So if it's negative 2, you divide by negative 2. And then these cancel out, and these signs will cancel out, so I get x equals 15. Okay, so these are trickier ones with the multiple fractions. Hopefully you'll remember how to do those and get some good practice. Okay, one more example on this page. And this is talking about the check, so the formal check. So this one, this one's not as hard as the last few ones we did. When we multiply the bracket through the brackets, we get 2x minus 6 equals 3x plus 3. Okay, and then we're going to kind of do the same thing we've been doing. If I want to keep this term because it's x, and this one means I want to get rid of these two terms. So I'm going to subtract 3x from both sides. So that's like negative 1x or negative x minus 6 equals 3. Because I subtracted that 3x out. Now, to get rid of this negative 6 or minus 6, I'm going to add 6. So I get negative 1x equals, so I add 6 to that, I get 9. Now, it looks like we're done, but we're not, because negative x is not the same as x. So again, just like if that was a negative 2, we're going to divide both sides by whatever that number is in front. These cancel out, and I get x equals negative 9, because remember, positive divided by negative is negative. Okay, last page, I believe. Oh, maybe. Yeah, there's a bunch of questions on the next page. I'll just do a sample of these ones. A lot of these seem like we're repeating what we've already done. But we'll do them anyways. So here is adding fractions. Again, we want the common denominator. Now, let's not worry about that negative on the bottom. That's what this question's here for. Okay, so this is really the same thing as I could move that negative sign up there, and that's really what I'm going to do. Okay, so assuming that's a positive 5 and a positive 4, I'm going to want fractions with 20. Okay, so if I want to get that to be 20, multiply the top by 4. So that's a negative 12. Multiply this by 5. So remember, I'm moving the negative sign up there, so negative 3 times 5 is negative 15. Okay, and negative 12 plus negative 15, well, that's really the same thing as negative 12 minus 15, which is negative 27 over 20. And again, we want to keep that, the whole point of this question is keep that negative sign up the top. So I would probably even do a intermediate step where I'd change it to -3/4 even before this. Okay. This one here, this is a mixed fraction divided by an improper fraction. So let's look at that one. So the first thing we want to do is change this to improper. Okay, so you got to be careful when the mixed fraction is negative. So I'm going to put my sign right away. And I know the denominator is going to be 8. So ignore the negative sign for now. 7 times 8 is 56, plus 1 is 57. So that is actually correct. A lot of times people would say multiply -7 times 8, that's -56, and then add 1, that's -55. That would be wrong. So almost ignore the negative sign until you do your final answer, or maybe just put it out front to begin with, and just multiply the positive numbers to and add the top. Okay, so that did that fine. And we're going to flip this to turn it into a multiplication. So that's 2/3 multiplied by 2/3. So now we're going to look to see if we can reduce. And this is a great example of being able to do that. So the first thing I see is the 2 and the 8. So I'm going to divide both of those by 2. So that 8 divided by 2 is 4. 2 divided by 2 is 1. This is the one that's going to save us a lot of time. 57 can be divided by 3 as well as 3, obviously. So divide that by 3, it's 1. Divide this by 3, it's -19. Okay, so when I multiply out now, I get -19 times 1 over 4 times 1. Okay, now if we didn't reduce there, we'd have a pretty awful looking fraction that we'd have to try to reduce. It takes a lot longer to do it if you do it then than when we do it at the beginning. Okay. I'm going to skip that one. We've already done examples of that. You're basically going to combine the x's and the constants together. Yeah, we've done these two and these. So I'm gonna skip those. Those are kind of repetition. Now this back page, this question here at the bottom, kind of a word problem. It's basically all you're really doing is it looks harder than it is. It explains that the index is represented by I, and these are heartbeat measurements, and these are duration. So this is really just an exercise to know what these values are in terms of A, B, C, D, and I, and plug them in and evaluate the variable you want. And in this case, how long a person was exercising, well, that is the D variable. So in this case, we're going to know what I is from here. We know what A, B, and C are. Plug them in and then just solve for D. So that's a little bit trickier. And up here we have a whole collection of some pretty good sampling of solving equation questions. You can see there's quite a few with the double fractions. In this case we have a triple fraction. So I'm going to leave that for you guys to work on. If you can, to me the most important thing to learn from grade 9 was solving equations. So it's really important going forward, grade 10, 11, 12, that you can do this, because it's a really valuable skill. Okay, so that's all there is for the first two days of review. So if you can work on that, I don't want this to take a ton of time for you. I know there's a lot of questions, but I do need you to have that level of skill, level of knowledge from these questions. So I'll post another video following this with day 3 and 4. But again, take your time. Listen to a specific part and then do the questions, and then check in with me in school or online to get some help for the ones that you're not sure about. Okay? All right, guys. Have a great day.